All right, I've got another problem to try to do for our domain and range question from section 1.1. This one is an absolute value. So an absolute value essentially is a distance from zero, and thus a negative value can never be a distance. So basically what we've been taught is to just find the value and make it a positive value. So if we take a look at this, our smallest value of, I guess we can use any x we want. So our domain will be negative infinity to infinity. There's no restriction on what we can do for domain. We can put any x value in there. There's no fraction. There's no issue about a zero in a denominator or anything like that. So our domain can be anything. But as far as our range goes, the smallest value that we could get for an absolute value is 0. And that occurs at x equals negative 5. So at x equaling negative 5, we have f of x, which is f at negative 5, will equal 0. So that's the smallest value you can have, and our range is anything above that. So our range will include 0 and go to infinity. And if you recall, our a graph like this is going to look, so what do we have? Negative 5. So negative 1, 2, 3, 4, 5. So right here, it's going to look like a little V. That's basically what the absolute value looks like. So this one has a 0, unlike the other one, which never actually touched either axis. This one's got a 0, so we have a 0 at that negative 5. And the other question that they want, do we have any intercepts? So a 0 is going to be an x-intercept, and a y-intercept is what we do when we put in 0 for x. So our y-intercept equals f at 0, which equals 4 times 0 plus 5, which is 20. So this is our y-intercept. So we're at 0 and 20. And now note that I've got parentheses around this. This is different from notation of a range. A y-intercept is going to be a point. So contextually, you have to know that this 0, 20 is a point and not the interval from 0 to 20.